For this example, we're going to determine if triangles CDE with vertices at C, which has the coordinates 2 and -2, vertex D, which has the coordinates at -4 and 2, and the vertex E, which is at point 4 and 1, is a right triangle. Keep in mind that a right triangle is a triangle that has an angle measure in it that's 90 degrees. So I'm going to use graph paper here, and you should too. It helps visualize what's going on. It helps us get a clear idea of what's happening. I'm just going to put in my axes here. This is the y-axis, or vertical axes. And of course, here's our horizontal axes, our x-axis. I'm just going to go ahead and then plot these vertices, these points, and then draw the go ahead and draw the triangle. So we have point C at 2 and -2, 1, 2. So here's point C. Here's point D, vertex D, at -4 and 2, 1, 2, 3, 4, 1, 2. And of course, point E, or vertex E, which is at 4 and 1. 1, 2, 3, 4, and 1. So it's easy to see how our triangle develops. So I'm just going to go ahead and connect these line segments. So not bad. So we can certainly see how our triangle looks. In order for this triangle to be a right triangle, it has to have an angle that's 90 degrees, or where two of the line segments have to meet up at a perpendicular, their slopes have to be perpendicular. So either segment DC right here, where it meets up with segment CE, if the slopes of these segments are opposites and inverses of each other, then they're perpendicular to each other, thus then they form a 90-degree angle. Or it could be segment CE and segment DE. If their slopes are opposites and inverses of each other, then this angle meets up at 90 degrees. So we'll go ahead and we'll use the slope formula to determine that. That's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'll label maybe this coordinate x sub 1, y sub 1, and this coordinate x sub 2, y sub 2. And it doesn't matter which coordinates you label as x sub 1, y sub 1. The slope will always come out to be the same. So we'll find the slope of this segment here, segment DC. So that's going to be -2 minus 2 and 2 minus -4. Two minus 2, that's -4. And 2 minus -4, that's the same as 2 plus 4, that's 6. So this simplifies to -2/3. So the slope of this line segment here, segment DC, has a slope of -2/3. Now I'll mark this vertex, this point right here, as x sub 1, y sub 1. And we'll find the slope of this one here. If the slope of this line segment here is the opposite and the inverse of this slope, then we know that these two segments are perpendicular to each other, thus forming a 90-degree angle. So we'll do that. -2 minus 1. And then 2 minus 4. Negative 2 minus 1, that's negative 3. And 2 minus 4, that's negative 2. So this comes out to be 3/2. So 3/2 is the opposite and the inverse of negative 2/3. So the slope of segment DC is negative 2/3. And the slope of segment CE is 3/2. They are opposites and inverses of each other. Or if we go ahead and multiply these two slopes together, it'll come out to be negative 1. Thus, these two segments are perpendicular to each other. Therefore, they form a 90-degree angle. And since they form a 90-degree angle, then triangle CDE is indeed a right triangle.